All right, so we are starting our review day. This is a review day on vectors, and we're going to everything we've done already, which is quite a few things. I'm going to be reviewing with you today. Not even everything, because the stuff we learned in the first day was so basic that we probably aren't going to even review that. All right, so at this point, you've learned a lot about 3D vectors. What you can't see for those that are listening at home on the video is I have a string set up that goes from the ceiling to the floor, and I got another one that goes from wall to wall, and that gives me my x and y axis. Which way would z be then? No, this one's x, this one's y, and where would z be? All right, now if we're talking vectors, it wouldn't be x, y, and z. What would it be? I, j, and k. Okay, so what's this way? I'm moving left to right for those at home. Okay, that would be I, and then going up and down, that would be j, and then in this scenario, again, you can make the 3 dimensions any way you want when you get to draw your own diagrams, but the third one would be k, and that can be towards you or away from you, okay? So I want to know this ball that I'm putting in the air here. Right now it's at 0, 0, 0, okay? But if I were to move it approximately there and say that my vector goes from 0, 0, 0 to there, what would you say that spot is? How far over? And this is in feet, by the way. So what I, what j, and what k? Right there. Write it down on your iPad. I want you to compare with the kid sitting next to you, and then you guys can argue about, no, it's definitely higher than that, or more than a foot. More than a foot over. Your eye should be more than a foot. Maybe I could argue it could be 2 feet or maybe 1.5 feet. What do you guys think? Okay. And then how about the up, the J? About 2 feet up. Okay. And then how about the K, which is the distance back or forth? Half a foot, you think? It's only 6 inches back? It's more like a foot back. It's a perspective thing. It's really hard to tell. But I'm going to say it's more like about a foot towards me. So therefore, I think you should have said about 1.5 I plus 2k plus, now should that be plus or minus from your perspective? Minus 1j, or just k, sorry. Okay. Minus a k. All right, good. So that, remember, the ball is not the thing. That's what it's pointing towards. The thing really is a vector coming out of the origin and heading to that spot. I know I'm moving it a little bit, and that's okay. All right, so the next question is, what if I had another vector that was generally heading that way? Do you get that you have learned how to figure out the angle between the two vectors? Write down the formula that you remember finding the angle between those two vectors. I'll remind you it involves a dot product. You haven't got this memorized yet? Write it down when I write it down and memorize it. You got to know it. Pause for a second while you do that. So the formula, sir. Writing it backwards, but I like it. Vector A dot. This is a dot, not a multiply. Vector B, I agree so far. Over the magnitude of A. Look at you using those big words. Times magnitude of B. I have a new word for you. If your magnitude, which often comes out from a square root, you know what I mean? Like if we have 2i plus 3j, do you get the magnitude of that is based on it going over 2 and up 3 And so it's a line here that's like a triangle, and I can figure out its magnitude by going square root of this imaginary triangle here of 2 and 3. This would be 2 squared is 4, 3 squared is 9, 9 and 4 makes 13. That guy's magnitude is root 13. Know what I'm talking about? Okay, that's the magnitude, but if it comes out to be a square root that is still that you can't simplify down to just a whole number, like in other words, square root of 36, we just say 6. But a square root of 37, that's called a surd. Did you notice the very first problem of the homework I told you to skip? Because it was asking you to find the surds. And I needed to look up for you first before. I knew it was a simple question. It's the first problem of the homework, but it was just to find the length of the thing. But its magnitude, if it happens to come out to a square root, which it usually does, if it happens to simplify down, it's not usually called a surd. It's just magnitude is like 6. But if it comes out to like this one, square root of 13, you'd call it a surd, S-U-R-D. New word for you. The surd bird. All right, so this, you'll need to be able to do dot products. You'll need to be able to find magnitudes of them, which are sometimes going to come out to surds. Yeah, not a big deal. If you don't know that word, you'll still pass the test. And then how do you follow, like in the end, how do you solve this thing? It's not solved for theta, inverse cosine. So technically you could have, if you really wanted to be fancy, solved for theta by doing inverse cosine on both sides. The cosine would cancel and it'd just be theta equals inverse cosine of all that. Okay, good. You'll need a graphing calculator for this little quiz you're about to take, because to find that angle between, last thought on that is, do I want the angle in radians or degrees? I would say degrees in this context. So have your calculator set so that it'll give it to you in degrees. If you want to borrow one from me, you may. Let's make that quick. All right, so the question was asked, do we need to know the unit vector stuff? Definitely. Let's talk about that in the context of this ruler again. So you know that a ruler that's a meter stick is how many centimeters? 100. Okay, so this is, if I'm going to go in centimeters, what's the magnitude of this meter stick that I'm holding up right now and pointing at a jaunty angle here? That is 100 centimeters. All right. Okay, so that's magnitude is 100. What if I shrunk it down and had a magnitude of only exactly 1, but it was pointing in the same direction? 1/100th of this. So I would find the equation for this and times it by 1 over 100. All right. So it's 1 over the magnitude times that vector. And then now I'll have a super short little vector that's still pointing in the right direction. Okay? Why is that good? Why is it handy to have that little vector? Make it whatever you want. So what if I want this thing to not be 100 centimeters, but I want it to be 400 meters? Just multiply by 400 meters. You take the unit vector, times it by 400. Good question. Remember, it was scaled down to just be 1. And by the way, these don't have units anyways. But don't worry about the unit thing. I'll just not even say units. I'll just say you want it to be 600 long. Okay, then the unit vector is pointing in the right direction. Just times it by whatever you want, 600. Okay, all right, so let's see how much of this you remember. It's 7 points, which will be scaled up in the grade book. Probably make it out of 14, which would be comparable to a lab. So do your best. This should be easy ones for you. Okay, and that also means you can't, not in the summative. This labs go in the formative also. But I'm just trying to say, this will count. Do your best. 7 questions. You can't look at anybody else's paper. You can't ask people for help. Okay, because this is, at this point, all review, and I'm just checking your progress. If it's terrible, I'll let you redo it if you have to, but all right. So here is 7 questions about the 2 vectors. I'll read through them so there's no questions about this. Vector V and vector M, the black one and the red one, write them both as column vectors. That's an awfully easy point. Number 2, find the magnitude of both, and if necessary, write them as a surd. Don't let that freak you out. If you don't know what that means, you're probably going to do it right anyways. Number 3 is the V with a little hat. I'd hate for anybody to get that wrong to not know what that was. What is it? The unit vector. So you're finding a unit vector for V and for M. For number 4, you're going to make a vector that has a magnitude 7 in the same direction as v. Number 5, the dot product, v dot m. You're not multiplying the two vectors, you're doing the dot product. It's different. And number 6, you're adding the vectors. As simple as that. Don't overthink that one. I just wanted to remind you of something from the first day. And number 7, what's the angle between those two vectors? Okay, take your time, do a quality job. Your homework for tonight, should you finish this earlier than other kids, some people will be done with this in like 7 minutes, and other people will take 17. If you finish, your homework for tonight is to just take the ones I told you to skip yesterday and now do them. Okay, so it's truly a review day. Go back to the same assignment, and I had you skip some trickier ones, and the ones at the end, there was like 3 more angle ones at the end of the assignment. Get those done. So everything you skipped before on last night's homework, they are assigned for tonight. So you could go work on them when you're done with this. All right, I will pause while the kids are working on this. So we are done with the quiz now, and kids have exchanged, and we're grading papers. And here is, it's a little messy here, but I'll talk you through it. Number 1, write them both as column vectors. Okay, so that's this column vector 2, 3, 4. That's the first one. And then the other one, of course, is, hold on a second here, the other blue one, 4. Okay, 2, 3, negative 4, yes. And the other one is 4, 2, 1. Any questions on those? And not seeing any hands. I'm going to move on. Number 2, the magnitude. These are surds. Why? Because the square root of 29 can't simplify. You just leave it as square root of 29, and that is a surd. They didn't have to label that as a surd or anything. Just square root of 29 is the first one's magnitude. And the next one's magnitude is square root of 21. Some people have expressed concern that it's the square root of 3 numbers. Yeah, if you just left it as the square root of the 2 squared and the 3 squared, it wouldn't take into account how deep it went. And the ray definitely needs to get longer. If it needs to go a fair ways away from you, then the ray has to, the vector has to get longer. So you need all 3 numbers underneath that square root. Okay, moving on to number 3. That little hat is called the unit vector, and it is this 7 is not there yet. That'll happen when we do this, but it's 1 over the square root of 29, and then I have a column vector there of 2, 3, negative 4. The way I had you do it on your homework was to say 2i plus 3j minus 4k. Yes, sir. It's a big deal, so you're going to have to take off a half a point. If that's our only mistake, just take off half a point. The other one's 1 over square root of 21, 4, 2, 1. And it could be 4i plus 2j plus 1k. Questions? Yes? I get that the square root's in the denominator, but what's on top? Oh, okay, so they put the whole thing in a big fraction bar and then put the root 21 on the bottom of that. That is equivalent. Number 4. Number 4 is you wanted to take the v vector and go the same direction as it, but have a magnitude of 7. So you take this unit vector back here and you put a times 7 in front of it. So 7 times all that. Now the 7 would end up going on top if you want to put the 7 as 7 over square root of 29. That would have been okay. Number 5, dot product. You multiply the 2 and the 4, this 2 and this 4, and this 3 and this 2, and that makes 6. So 8 and 6 makes 14, and then a negative 4 times 1 is a negative 4, that makes 10. Dot product is 10. And then number 6, add the vectors. That's just as simple as adding each little element. 2 plus 4 makes 6 over 5 over negative 3. If they wrote them as column vectors. If they wrote them out as position, it's the same thing except with I, J, K. And the last one, angle between them. All right, here's the formula written out again. I'm going to move this part over for now. Okay. And there, the thing circled in green, that would be the dot product is equal to the 2 magnitudes, which are surds, times cosine of theta. Then to solve it all, you're going to do inverse cosine of 10 over this part. I'll move this part in here now. 10 inverse cosine of 10 over root 25 root 21, which ends up being 66 degrees. If they did it in radians and didn't note that they was in radians, mark it. I guess I'll give them half. But I doubt anybody did that. So, did anybody do it in radians? Okay. All right. Now, put CB in your name and the score at the top out of 7. It's out of 7 points. I will double it later if I'm going to, but you just give them a score out of 7. Okay, that's all I got. Pause for you while you hand those back. All right, so this next part is just to talk 3D for a minute and make you think about the world in a slightly different way than you maybe have before. I'm going to stop the video because it's not something that's necessary for kids to know. It's just a demo that you're not going to be able to see on the video anyway. So that's all I have for the video for today. Tomorrow we'll get into some heavy-duty new vector stuff. So watch the next video.